Hi friends, this is Srinivas. In this video, I will explain about sp3d hybridization. Okay, sp3d hybridization. In this hybridization, one s orbital, three p orbitals, and one d orbital. Totally five pure atomic orbitals. 1, 2, 3, 4, 5. Five pure atomic orbitals are intermix each other. Okay, five pure atomic orbitals are intermix each other to form same energy and same shape and identical orbitals. How many? Same number of how many atomic orbitals? 5. So 5 hybridized orbitals. 5 sp3d. 5 sp3d hybridized orbitals are formed. Okay. Now listen. 5 pure atomic orbitals intermix each other in this hybridization. 5 pure atomic orbitals. One s orbital, 3 p orbitals, 1 d orbitals. Okay, so this is the sp3 hybridization. In this hybridization, s character 20%, p character 60%, and d character 20%. Look at here all of you once. Here one s orbital is there. It is 20%. P orbital, one orbital is 20%. Another orbital 20%. Another orbital 20%. Last d orbital 20%. Overall, these all are equal to 100%. Overall, these all are equal to 100%. Okay, S character 20%, P character 60%, D character 20%. Okay, each orbital contribute same energy, same. Okay, that's why these all are have 5 identical orbitals, sp3 orbitals. Okay, now friends, this is the sp3 hybridized orbital. It means these are the orbitals involving the sp3d hybridization. Okay, it means it is 1 by 5th. It means 3 by 5th. It means also 1 by 5th part shape in the hybridization. Okay, next we have how to discuss about this structure. Okay, here bond angle in this hybridization 120 degrees and 90 degrees. Okay, two different angles are there in this. Okay, and its shape is sp3d hybridization shape is trigonal bipyramidal. Its shape is trigonal bipyramidal shape. Trigonal bipyramidal shape. Bond angle 120, 90 degrees. Okay, here S character is 20%, B character is 60%, D character is 20%. Okay, this is the sp3d hybridization. Listen, here bond angles. Here we have discussed about bond angles. The bond angle between bond angle between equatorial orbitals is equal to 120 degrees. Okay, next bond angle between axial and equatorial orbitals is 90 degrees. Okay na? That's why due to this bond angle, axial hybrid orbitals have more repulsion. The axial orbitals have more repulsion. These are got more repulsion. Due to the more repulsion, the axial bonds have more bond length also. Due to this bond angle, these axial orbitals have more repulsion. Due to the more repulsion, these axial bonds are having more bond length also. Due to the more bond length, these sp3 hybridization, sp3d hybridization, sp3d hybridization participate in a chemical bond easily. Okay. This is the so now listen, bond length. Bond length in axial. Bond length for axial orbitals. For axial orbitals. Axial orbitals is equal to 2.04 angstroms. Okay. Next, bond angle in bond length, LNGT, bond length for equatorial. Axial is 2.19 angstroms, and equatorial is 2.04 angstroms. 2.04 angstroms. That's why axial bond length is more, equatorial bond length is less. Due to this bond angle, the bond angle between axial and equatorial orbitals, the bond angle between axial and equatorial orbitals, the repulsions are more. The repulsions are more. Due to the repulsion, listen, repulsions are occur between axial and equatorial orbitals due to bond angle between due to bond angle 90 degrees, bond angle 90 degrees between axial and equatorial orbitals. Axial and equatorial orbitals. Okay, friends, this is the sp3 hybridization. How to write that structure also. This is central atom. How to imagine central atom. This is central atom. Around the central atom, 5 sp3d hybridized orbitals are arranged. This is also one of the sp3 hybridized orbital. This is also 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 sp3d hybridized orbital. Okay, friends. Okay, these 5 are sp3 hybridized orbital. These 5 are sp3 hybridized orbital. Okay, so listen, look at all of you. These are called equatorial orbitals. These are equatorial orbitals. This is also equatorial, this is also equatorial, this is also equatorial. These all are in the same plane. These all are in same plane. Equatorial orbitals. These all are equatorial orbitals. These all are in same plane. This is axial. This is axial. This is also axial. These axial orbitals, one is above the equatorial orbitals, one is below the equatorial orbitals. These are equatorial orbitals. It is also equatorial orbital. It is also equatorial orbital. Equatorial orbitals are in the same plane. Equatorial orbitals are in same plane. Are in same plane. Same plane. Okay. Axial orbitals above the equatorial. One is above the equatorial orbital. Another is below the equatorial orbitals. Okay. The bond angle between two equatorial orbitals. The bond angle between two equatorial orbitals is 120 degrees. 120 degrees. The bond angle between one equatorial and axial is 90 degrees. Due to this bond angle, the repulsions between equatorial and axial orbitals have more repulsions are produced. Okay, due to this less bond angle, the repulsions are occur between equatorial orbitals and axial orbitals. Okay, here repulsions are also there. Repulsions due to the less bond angle. Due to this repulsions, the bond length of axial and equatorial. Okay, axial is more. Bond length is bond length. Axial is 2.19 angstroms and equatorial is 2.04 angstroms. Okay, so bond length is more in axial, less in equatorial. Due to this bond length, this sp3d hybridization more active, because of here bond length is more. Whenever bond length is more, the bond energy also less. Whenever bond energy is less, it will be participating more in chemical reactions. Okay, na? This is the sp3d hybridization. This is the sp3d hybridization. We have to discuss about sp3d hybridization example. Okay, na friends? Now the example of PCl5. Okay, sorry, the example of sp3d hybridization. The example is PCl5. Okay, PCl5 is example of sp3d hybridization. Okay, PCl5 is example of sp3d hybridization. PCl5 is example of sp3d hybridization. Okay, friends. Now look at here. In the PCl5, central atom is phosphorus. Phosphorus atomic number is 15. Phosphorus atomic number is 15. Its electronic configuration neon 3s2 3p3 3s2 3p3 3d0 3s2 3p3 3d0. Okay, na? Now we have to write expanded electron configuration of ground state electron configuration of phosphorus. Okay, now neon 3s2 3px1 3py1 3pz1 3d0. It is ground state electron configuration. Ground state electronic configuration. Now from this ground state electron configuration, one of the electron 3s2, it will be jumps. One electron jumps from 3s2 to 3d0. Jump. It will be excited. It means excited. Neon 3s1 3px1 3py1 3pz1 3D1. Now in this it is excited state electron configuration. Excited state electronic configuration. In this excited electron configuration, we have five unpaired orbitals are there. Five unpaired pure atomic orbitals are there. In excited electron configuration of phosphorus, we have five unpaired pure atomic orbitals are there. These are okay. These five unpaired orbitals are participate in sigma bond. It is also participate in sigma bond. It is also participate in sigma bond. It is also participate in sigma bond. These all are participate in a sigma bond. That's why these five orbitals are involving in hybridization. These five orbitals are involving in hybridization. It means one s orbital from 3s, one p orbital from 3px, one p orbital from 3py, one p orbital from 3pz, one d orbital from 3d. Okay, d orbital. Overall, 1, 2, 3, 4, 5. 5 atomic orbitals. So total these are intermix each other. sp3d. This is the hybridization present in phosphorus in PCl4. This is the hybridization present in phosphorus in PCl4. Okay, now phosphorus. This is phosphorus. Okay, around the phosphorus, the hybridized orbitals are there. Around the phosphorus, the hybridized orbitals are there. Okay, around the phosphorus, the hybridized orbitals are there. How many hybridized orbitals? 5. One is like this. Another is like this. Remaining one is remaining another one. Okay, these are the sp3d hybridized orbitals of phosphorus around the phosphorus. Okay, these are the 5 sp3d hybridized orbitals. So these all are having same shape and same bond length and same energy also, but dichromatically small difference is there. Okay, these all are these are the sp3d hybridized orbitals. These are among these sp3 orbitals, these are equatorials. Okay, these are the equatorials. These all are in same plane. These are axial. Okay, the bond angle between two equatorial orbitals 120 degrees. The bond angle between two axial orbitals, equatorial axial 90 degrees. Axial and equatorial are 90 degrees. Okay, this is also sp3d hybridized orbital of phosphorus. This is also sp3d hybridized orbital of phosphorus. This is also sp3d hybridized of phosphorus in PCl5. This is also sp3d orbitals in phosphorus. It is also sp3d hybridized orbitals. Okay, 5 sp3 orbitals. These axial orbitals are above the equatorial orbitals. One is above the equatorial orbitals, another one is below the equatorial orbitals. These are the equatorial orbitals. Okay, this shape is trigonal bipyramidal. Here, this bond length is axial orbital bond length is 2.19 angstroms. Axial bond length is 2.19 angstroms. Equatorial bond length is 2.04 angstroms. Okay, now 2.04 angstroms. It means axial bond length is more, equatorial bond length is less. That's why, because of due to these repulsions, equatorial orbitals and axial orbitals. Due to these repulsions, axial orbitals have more bond length. Due to this bond length, in the PCl5, phosphorus in PCl5, it is participating more easily in chemical reaction. Okay, na? In the PCl5, with the 5 sp3 orbitals, we have a bond with chlorine. Okay, na? These 5 sp3 orbitals are bond with chlorine. Chlorine atomic number is 17. Atomic number is 1s2 neon, 3s2, 3px2, 3py2, 3pz1. Now this 3p Z1 orbital, 3p Z1 orbital, 3p Z1 orbital is bonded with sp3d hybrid orbitals. Okay na, of phosphorus. This 3p Z orbital bonded with sp3d bonded orbital. Okay na, how to draw another diagram, how to draw, because of how to maintain, how to give clear picture. Okay, now look at here all of you. Phosphorus, around the phosphorus 5 PCl 5 sp3 orbitals are there. These two are also sp3d axial. These are equatorial orbitals. These are equatorial orbitals. Okay, these are the equatorial orbitals. For the equatorial orbitals, for the equatorial orbitals, for the equatorial orbitals, for the equatorial orbitals, 3pz orbitals are bonded. 3pz orbitals are bonded. 3pz orbitals. This is also 3pz. 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 Okay, here this is 3pz. 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 3pz of chlorine. Once remember all of you, 3pz of chlorine. Okay na, these 5 3pz orbitals are bonded with sp3d orbitals of phosphorus. sp3d orbitals of phosphorus. sp3d orbitals of phosphorus. It is 3pz orbital. Okay, 3pz. It is sp3d. 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 Okay, these all are in sigma bonded. These all are sigma bonded. These all are sigma bonded. 5 sp3d around the phosphorus. 5 sp3d 3pz. Sigma bonds are there. sp3d sigma bonds. All are 5 sigma bonds. 5 sigma bonds are there. Okay, here bond angle is between two axial, between two equatorial 120 degrees, and between two equatorial and axial 90 degrees. Equatorial and axial. So here bond length is axial in 2.19 angstroms and equatorial 2.04 angstroms. The bond length of axial bonds 2.19, the bond of equatorial bond length 2.04 angstroms. Simply this diagram will have to draw like this. Chlorine, 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 chlorine. Here bond angle, this is the bond angle is 120 degrees. Here bond angle is 90 degrees. Okay, this structure is called simply trigonal bipyramidal. Trigonal bipyramidal. This structure is called simply trigonal bipyramidal. Due to the this repulsions between axial, equatorial and axial orbitals, repulsions here repulsions are occur. Due to the repulsions, the axial bond lengths are more. Axial bond lengths are more. Due to the axial bond lengths are more, the PCl5 involving in the chemical reaction more easily. Okay na friends, thank you. Please subscribe my channel and encourage me. Thank you.